Okay, let's dive right in. On any drilling site, there's one piece of gear that's the ultimate safety net. We're talking about the onshore blowout preventer stock, your absolute last line of defense when things go sideways. And for anyone in safety management, you know understanding this system isn't just important, it's fundamental. This quote from our source material really says it all, doesn't it? The stakes just couldn't be higher. We're talking about a massive mechanical barrier that protects lives, millions in equipment, and the environment from these catastrophic forces building up right below the surface. So, over the next few minutes, here's what we're going to cover. We'll start with the threat itself, then we'll get into the anatomy of the BOP stack. We'll look at the hard data on safety, talk about what it takes to keep these things ready to go, and then wrap up with the most critical piece of the puzzle, the human factor. Right, so let's start with the why. Why does this incredible piece of equipment even exist? Because to really appreciate the solution, you've got to understand the immense power it's designed to contain. So a blowout? That's what happens when the pressure downhole just completely overwhelms everything you're using to control it. You've got hydrocarbons rocketing up the wellbore looking for any way out. And without a failsafe, well, that's an uncontrolled release that can ignite, causing fires, explosions, just devastating damage. This is the exact scenario a BOP is built to prevent. So how in the world do you stop that kind of force? Well, you fight fire with fire. Or in this case, you fight force with an even more powerful, purpose-built piece of engineering. Let's break down the anatomy of this defender. Think of the BOP stack as the emergency brake for your well. It's basically a series of incredibly powerful, hydraulically controlled valves that are designed to slam shut and create an immediate mechanical seal. We're talking about containing pressures that can top 10,000 psi. When every other method has failed, this is what you're counting on. Now, you've probably seen pictures of those massive BOPs they use for offshore drilling. Onshore systems, though, they're a different animal. As you can see here, they're usually smaller, they operate at slightly lower pressures, but, and this is key, they offer direct ground-level access for maintenance. And that accessibility, it's a huge, huge advantage when it comes to keeping the system ready. The real backbone of the stack is the ram preventer. I mean, these are just incredibly powerful hydraulic rams that close with a tremendous amount of force to create a seal. They are the brute force solution, physically blocking off that wellbore. And they come in a few specialized flavors. You've got your pipe rams, which are shaped to seal perfectly around a specific size of drill pipe. Then you have blind rams, basically two solid blocks of steel that meet in the middle to seal off a completely open hole. And then the shear rams. These are the ultimate failsafe. They can literally slice right through the drill pipe and then seal the well. Now, sitting on top of the rams, you'll find the annular preventer. This is the finesse player. Unlike those rigid rams, this uses a flexible, kind of donut-shaped rubber element that can squeeze inward and seal around pretty much anything in the wellbore or even seal an open hole. Its superpower is versatility. And this is what's so brilliant about it. The annular can hold all that pressure while still letting the crew rotate or move the drill pipe. That is incredibly valuable during a well control event. It gives the operators way more options than just a hard total shut-in. Of course, all this heavy-duty hardware is useless without a brain and some muscle, right? Well, that's the control system. It's the nervous system that takes a driller's split-second decision and turns it into immediate, powerful mechanical action. So the key parts here are the hydraulic accumulators. These bottles store fluid under immense pressure, just waiting to be released instantly. You've got the remote control panels, which let operators activate everything from a safe distance. And absolutely critical, multiple backup systems ensure there's redundancy. Because in this game, failure is simply not an option. Okay, so we know how it's supposed to work, but how effective is it, really, out in the field? This is where the data gets incredibly compelling, especially for anyone managing risk. Now, what's so amazing about this slide is this one number, 98%. Let that sink in. When a boat stack is properly maintained and tested, it successfully contains the incident almost every single time. The equipment fundamentally does its job. And we can see the impact of that focus on readiness. Ever since the industry brought in these enhanced BOP testing protocols, there's been a 65% drop in blowout incidents. I mean, that's a direct, measurable line between having rigorous procedures and getting safer outcomes. So here's the kicker. If the equipment is so darn reliable, where did the other failures come from?
This chart tells the whole story. A staggering 75% of failures, they're not due to the hardware breaking down. They're attributed to human factors. Things like poor procedures, not enough training, or just responding too slowly.
And that brings us to the most actionable part of our whole discussion. If the human systems are the biggest variable, then building bulletproof protocols for maintenance and testing, well, that's the solution. It all starts with a daily routine that is absolutely non-negotiable. A visual walk-around, cycling every single function to make sure it moves right, checking that accumulator pressure, inspecting the seals, and, this is critical, documenting absolutely everything. These simple, consistent actions are what stop failures before they start.
And all that daily work is backed up by a really rigorous schedule of pressure testing. As you can see here, you've got different kinds of tests: low pressure, high pressure, function tests, and each one has its own frequency and parameters. This is how you prove, under controlled conditions, that the whole system will hold when you need it most.
All right, so let's circle back and tackle that 75% statistic head-on. Because having a perfectly maintained BOP is one thing, but having a crew that can actually use it effectively under extreme pressure, that's a whole other ballgame. An effective response doesn't just happen by accident. It's built on having crystal clear triggers for when to activate the BOP. It relies on emergency drills that create muscle memory. It uses tiered protocols so everyone knows when to use a soft shut-in versus a hard one. And none of it works without seamless communication from the rig floor to the control room. And that really brings us to the bottom line. The BOP is your last line of defense, for sure, but it's your safety protocols, your training, your daily procedures. That's what guarantees that defense will actually hold up. The integrity of that stack has to be a daily operational priority for every single person on that rig.
So I'll just leave you with this one question to think about. The data shows your equipment is 98% effective. As a safety leader, the real question you have to be asking yourself is, are your people and your procedures just as reliable?